So today is day 5 for your notes. You should all have the notes packet that you're following along with. Our focus is the number line, opposites, so positive and negatives. Today's the first day we'll start looking at negatives. And then we'll also talk about absolute value, and that'll finish us up for chapter 1. Any questions? So your notes start out with a number line. Are you guys familiar with the idea of a number line? Okay, typically in the middle of a number line you'll see a 0, and then everything to the right, those are the positive numbers, and everything to the left would be the negative numbers. Okay, and we call all the numbers that you can graph on a number line real numbers. Real numbers are the only types of numbers we'll talk about this year, so don't get too excited. But when you get into Algebra 2, we'll talk about the other imaginary numbers.
So would like 3.2 be a real number?
Yes, 3.2 would be a real number because you can find it on the number line. Okay? So we'll start talking about whole numbers. Here's an example of the whole numbers. Whole numbers are all the counting numbers, like numbers you count with, 1, 2, 3, 4, 5, 6. It also includes the 0. The way I remember that is it kind of looks like there's a 0 in the middle of the word whole, right? Whole numbers include zeros, okay? Positive integers are all the whole numbers to the right, the numbers you count with, the 1, 2, 3, 4, so no decimals, no fractions. Negative integers are to the left, the -1, the -2, the -3, and so on. And then when you put them all together, integers are all those numbers that don't include the fractions and the decimals in both directions. So all the positives, all the negatives, and that 0 make up the integers. Any questions? All right, let's keep it moving. So here's our first example. We're going to use that number line. You can see that we have 4 points on this number line. The location of it is called the coordinate of that point. So the graph of 2.5 is, so start at the 0. We're going to the right 2.5. What point is right there? D. Very good. And then the coordinate of C. So -3. Very good. So again, this is, bless you. This is, this is the graph of these numbers on a number line, okay? What is the coordinate of A? You can just say, yep, 6, very good. And then, of course, B is at -1, and C is at -3, and we already talked about D. Any questions on this idea of graphing numbers on a number line? So we are going to come up with an integer that represents this situation. So if you have a 5-yard loss, like if you're playing football and your team goes back 5 yards, what kind of number could you use? A negative. Very good. So a way to represent that, a 5-yard loss would be -5. Now, we also want to talk about, well, what would the opposite of a 5-yard loss be? And it'd be the opposite, right? A 5-yard gain, which would be +5. And when it's +5, you don't put a plus there. That's not necessary, okay? Positives don't have anything in the front. Negatives have a negative. Questions on part A? All right, here's part B. So if you're playing the stocks on the stock market, if your stock rises 3 points.
3.
Yeah, just regular 3. Good. How would you describe the opposite?
-3.
What, like in words, how could you describe it?
Stocks down 3.
Yeah, going down 3 points, or decrease 3 points, or your stock dropped 3 points. Right. If you ever watch the news, sometimes you'll hear this, like the Dow Jones dropped so many points. That's what they mean. It's a -3. Questions? A 3-game losing streak. This makes me think of baseball right now. Everyone's talking about like this team's up 2 games, this team's down half a game, right? So if you have a 3-game losing streak, Yes. Good. So if you're keeping track of your overall record, losing 3 games in a row would be pretty bad, right? That's going to take you down 3 or negative 3. And then the opposite would be obviously a winning streak, which would be positive 3. Any questions so far? All right, next we are going to translate this into symbols. Negative 7 is greater than negative 33. So negative 7, we just use the negative sign, right? Negative 7 is greater than. Anytime you see the is, you're probably going to have an equal sign or one of the inequality symbols. So is greater than, we have this guy. It's like the big mouth opening to the number you just talked about. That's kind of how you learn it the first time around when you're younger, right? And then in the back, we finish it off with negative 33. Questions on that one? Pretty straightforward. So in number 4, we have 2 numbers on the number line, right? What are the 2 numbers that are graphed right now?
Negative 3.
Yep, good. Sorry, negative 3 and 2. Perfect. Do you know which one's smaller? Negative 3. So you can start with the negative 3. It's smaller, so we'd have to use the less than symbol than the than the positive 2. Or you can start with the positive 2, which is the larger value, so then you have to use the greater than symbol. And this is a lot easier when you're using a number line because things to the left are always less. So the farther to the left, the less value that number has. So this one is smaller than this one. Or if you write it in reverse, this guy is bigger than this one. What are your questions on this? All right, who's bigger, 2 or 7? 7. So we want the less than symbol between those 2. Now this is one where you might want to picture a number line. If we had a number line, I'll draw one real quick. You don't need to draw one necessarily. Negative 6 would be over here, and then you'd have negative 5, and then you'd have negative 4. So what's bigger than negative 4? So the symbol would be greater than. Good. Okay, this one is actually not as hard as it seems because if I was putting this on a number line, let me just really focus in on one little portion of the number line. What 2 numbers would 2/3 fall between?
1 and 2.
The 0 and the 1, right? But on the negative. So that would be right here. Ish, you know. This is almost 12 over 6. 12 over 6 would be 2, right? So it's almost way down here. So according to where they're located on the number line, just a quick sketch of the number line, it looks like the negative 2/3 is farther to the right. So I would need the greater than symbol. That's kind of the easy way to do it. I would also call that the less accurate way to do it. You might have to change them to decimals on some of these, and if those come up, I'll show you how to do that by hand. But I would just kind of eyeball these, especially still until we start using calculators in here. Nobody really likes going from fractions to decimals when they don't have to. Any questions? All right, here is example 6. We want to graph these numbers on a number line. Then list them in increasing order. All right, so just go number by number. 1.5, that's halfway between the 1 and the 2. This one, it's bigger than, it's like 3 over 3 would put it right at the -1. And it's a little farther than that. So just go a little left of the -1. That's where we'll put that guy. +2, that's an easy one. Then the -4, so just left 4 spaces if you're starting at 0 each time. +3. And -2.75. So would that be closer to the -3 or the -2?
-3.
Yeah, a little closer. All right, next we put these in increasing order. Increasing order means from the smallest number to the biggest number. A lot of times, honestly, I do a little more when I'm doing it on my own. I would even probably go through and label the dots as I went, just to help me like remember what number that was. And then when you get to this next step, it's a lot easier because you're just writing them out in that order from left to right as they appear on the number line. So if you want to add those labels on those, go for it. I think it's a little more helpful than not having the labels. What are your questions? And then I was talking about sometimes you do have to take the fractions to decimals when they're a little closer in value than the ones we've been looking at. You might have to do that through long division. If you do, for example, if you would have changed this to like -1.3, when you put it in your final answer, you always go back to the original form from the problem. So just be aware of that if it ever comes up. What questions do you have? So the definition for absolute value is a number's distance from the origin on a number line. Does anyone know where the origin on a number line is? Just say it, all of you. 0. So it's the distance from 0 on a number line. So let's talk about distance for a second. If I was going to measure from where I am right now to the door, let's say it's 15 feet, right? So let's say I get a tape measure out and I'm like 15 feet, right? Well, now let's say I want to go the other direction. Would this be -15 feet? No. Distance is never negative. Whether you're going, like from your house to the school, let's say it's 5 miles, you go home the same route, but backwards, it's still 5 miles. Distance is not something that we do negative. Distance is always positive. Absolute value is the measure of a number's distance from 0. So whether you're going to the left 5 spaces, to the right 5 spaces, it's still the distance of 5. So absolute value is always positive. Any questions on that idea of distance? So here is example A. And we show absolute value using these bars. So this is basically saying how far away from 0 is -2? 2 spaces. Good. How far away is 3? 3. I don't mind if you guys say the answers on stuff like this where it's kind of, I think a lot of us know the answers, right? I don't think there'll be any major brawls over the answer today. All right, here's where maybe it gets a little harder. So what is the absolute value of -3? You can all say it. 3. And what's 3 plus 3? 6. So you got to take care of the absolute value first. Absolute value is always positive. Unless it's 0, then it's just 0. So positive 3 plus 3, 6. Now, on this one, there's something you can simplify within the absolute value symbols first. You want to take care of that before you think of the positive. So do 22 minus 4, which is? 18. Were you going to say 18? Yeah. Yes, it is 18. And what's the absolute value of 18? 18. Any questions on that? Okay, this is where it gets kind of tricky. This is why I said when absolute value is always positive, that's kind of a lie. Because it could be 0. Yeah, 0 is 0 spaces away from itself, right? So absolute value can be 0. And 0 is not positive or negative. I know, I'm getting lost in the definitions. Absolute value can't be negative. That's how I should have said it. There it is. Absolute value cannot be negative. What are your questions? All right, opposites. 2 numbers which are the same distance. So how could you both be, let's say, 5 units away from 0? Yeah, one goes to the left 5, one goes to the right 5. So if we're looking for the opposite of -3, you can all say it. It would be 3. If we're looking for the opposite of 5, it would be everybody? -5. What is the opposite of -2/3? Everybody? 2/3. Questions? All right, this is where the concepts that we talked about today meet up with order of operations. So what does anyone have a thought? Yes? You add the numbers in parentheses first. So just 3 plus 2, that's 5. And then you have a negative out front. So it's kind of like the opposite of whatever you would get in the parentheses. Or yes, you could think of that as times a -1. And we end up with -5. Questions? All right. Let the bell ring.
No, that was for lunch.
Oh, yeah, I know. I just wasn't going to talk over the bell. I know what it's for. All right. We work from innermost parentheses or grouping symbols out. So when you work out, you would have -3. Then you would have a -3. What's a negative? Everybody? Okay. Good. I love that you're all raising your hand, but I think something like this we can just kind of, like a choral answer, I think is what they call it in the biz. Okay.
Negative.
Oh. I was going to say, everybody give everybody a second. So when you work out, you'd have -2. Then another one would give you a +2. Then a third one would give you a -2. So negatives become positives in pairs of 2. So if you have an odd number of negatives, you should end up, if you have 4 negatives, it'd be a positive. 5 negatives would be a negative. 6 negatives would be a positive. It kind of flip-flops back and forth.
All right.
So an even number, you should end up with a positive. An odd number, you should end up with a negative. So let's complete the first one together. Today we learned opposites. We also learned about absolute value. And did we learn anything else? Yes? Number lines, good. Now, the next two I'm going to let you do on your own, but they are extremely important because tomorrow we are reviewing. So anything you're still not sure of, we'll need to talk about tomorrow. And Friday, you have your first test. So all these sample test questions you've been writing for yourself at the end of each notes is a great way Thursday night that you can quiz yourself leading into Friday. And here's the kicker. I am grading the notes packets on Friday while you take the test. So make sure they are done and make sure that they're ready for me to look at because I'm, boom, doing it Friday. And if you took notes this whole time, that's like a big extra bonus grade for you leading into the test. Any questions?